Hello students, in today's session we are revising for IGCSE 0580 extended part, and the first unit that we are dealing with is numbers. Numbers is a very important part of any paper if I'm talking about paper 2 or paper 4. So it is a very vital part of it. The starting questions from both of these papers are based on the concepts on numbers. Now the first part that we are dealing with is the types of number. So that means how many types of numbers are there, integers or decimals. So the first part is this. That's types of numbers. Now, if I go about the type of numbers, so the first one is called decimals. So decimals is something where you have a point variable. So that means if I'm writing 7.6, so this is called decimal and this is one place after decimal. Now, decimals has got a lot of operations like addition, subtraction, multiplication, and division. So suppose if I want to add two decimals, so that's 1.2 plus 2.3. So we write like that 1.2 and that's 2.3 and we put a plus sign here. So we'll add 2 plus 3, so that gives me 5. Again, we'll place the decimal in its own place and 2 plus 1, so that's 3. So the final answer has to be 3.5. The other operation with decimals is once we are subtracting, suppose we have decimal 5.3 and we are subtracting 3.1 from it. So we'll write again 5.3 and that's 3.1 and we'll put a subtraction sign. So that's 3 minus 1, that's 2. And that's 5 minus 3, so that's also 2. So the answer has to be 2.2. Now, we can also have multiplication of two decimals. Say we have 1.1 and that's multiplied again with say 2.1. So that means we have 21. We first write 21, this digit, and multiply it with 11. So we got it as 21. We cross this place and then again we got it as 21. So that means this is 1. If we add, this is 3 and that's 2. So that means since there's one place after decimal here and one place after decimal here, so we'll add these two places. So the multiplication will be 2.31. As you can see, that decimal is now two places after the digit over here. So that's how the multiplication part works. Now, if I go for the division part of it, say suppose if I'm writing 2.1 and that's divided by 0.7. So in this case, we'll first change it into the fraction part. So that means I can write this as 21 by 10. So that gives me 2.1. Put a division sign and that's 7 by 10. Now, in division, always remember the first part will remain same as it is. So that's 21 by 10. Then we'll put a multiplication sign and reverse the second part. So that means it becomes 10 by 7. So we can cancel this 10 out and the answer that we got for this is 3. So 3 is the answer for the division. So these are the topics that we have, or these are the operations that we have in decimals which we have to do without calculator. So if it comes for a single mark, so you have to get the final answer correct with the operations so that you get 1 mark for it. Now, if it comes by any means for 2 marks, specifically for multiplication or division, so showing the intermediary steps correctly gives you a mark and the final answer gives you the other mark for it. Right. Now, the next topic that we are going for this under this head is the types of numbers. So the types of numbers, we also have fractions. So fractions is something where it's written in the form of p by q and where p and q are both integers. So in any fraction, it's written in the form of p by q where p and q both are integers. So in this case, say for an example, 3 by 5, we can also say it as 4 by 7. So all of these are fractions, and one more criteria should be that q must not be equal to 0. If q is equals to 0, so in that case the fraction becomes infinite and will not be able to represent it. So again, if I go by the fraction operations, so the fraction operations that we are dealing with, so we can have addition, again subtraction, multiplication, and addition. So we'll see all of those one by one. So suppose there are two fractions. We just take add 3 by 5 and plus 2 by 7. So if I want to add these two fractions, the first thing that I need to take is the LCM of these two. So the LCM of 5 and 7 has to be 35. So that means I need to make denominator 35. So I have to multiply this by 7. So if I'm multiplying the denominator by 7, so I have to multiply the numerator also by 7 to keep the fraction unaltered. In that case, this is 21. And again here, to make it 35, we have to multiply by 5. So that's 10. So that's equals to 31 over 35. And that's the addition of the two fractions. Similarly, if I want to subtract two fractions, say 5 by 2, and that's minus 3 by 2. So in this case, the LCM is 2 only, and we can get 5 minus 3. So that's 2 over 2, and we can cancel it out to write the final answer as 1. Number 3, if we want to divide two fractions, suppose we have got the fraction as 7 by 8, and that's divided by as 3 by 4. So first of all, we'll write the first fraction as it is, which is 7 by 8. We'll put a multiplication sign and reciprocate the second fraction. So that means it's written as 4 by 3. So we can cancel this out. And the final answer that we got is 7 by 6. Now, fraction multiplication is in most of the easiest part, where you just have to multiply the two fractions and write the final answer. So that literally means if 7 into 3, so that's 21, numerator to numerator, and denominator to denominator, so that's by 40. So that's the answer for the fraction part. Now, moving on to the other part is we have to have a combined operation on fractions and decimals. So that means we have a recurring kind of thing where in fraction a digit keeps on repeating itself. So we'll go for the recurring part also. Now suppose for an example, if I want to write 0.7 recurring. Now this dot is known as recurring. Recurring literally means that the digit keeps on repeating. So that means it's 0.77777 and simply goes on. In these type of problems, if I have to change it into a fraction, that's a very important part usually asked. So I have to assume that x equals to 0.77777 and it goes on like that. So now to bring this 7 right in front here, we have to multiply with 10. So that means 10x becomes 7.77777. Now if I'm subtracting, that means 10x minus x. So I'll get it as 7 because this part exactly nullifies. So that means the value of 9x is equals to 7, or the value of x that we got is 7 by 9, and that's how a recurring is converted into a decimal over here. Similarly, if you have two powers of recurring, that means if I'm having a number like this, which is recurring in pair, suppose 0.23, and we have a recurring over here. So that literally means that x equals to 0.23232323, and it goes on. So that means I have to bring now the two digits right in front over here. So I have to multiply it by 100. So 100x equals to 23.232323, and this part remains the same. Now, if again I subtract, so I got 100x minus x, and that's equals to 23, because again the part after decimal nullifies. So that means we got it as 99x as equals to 23, and x equals to 23 by 99. So that's how we convert it into the fraction part. This is very important, students. You should understand and practice this part very nicely. Now, moving on to the other part of this, if we are moving ahead, so we have number facts, which is sequence. Now, under the number facts and sequence, we have couple of topics. So I'll just place a couple of things over here. So we have an integer, which is positive, negative, whole number, or zero. So an integer is a positive or negative whole number or zero. So that means, as you can see, plus 2 is an integer, minus 3 is an integer. Now, what is a prime number? Prime number is divisible only by itself and by 1. So suppose 2 is a prime number because it has got only two factors, which is 2 and 1. So it's divisible by itself and by 1. Similarly, 3, 5, 7, 11, 30. What are the multiples of 12? Multiples of 12 means if I multiply 12 with an integer, I should get that number. So if 12 is multiplied by 1, I get 12. If 12 is multiplied by 2, I get 24. If 12 is multiplied by 3, so I get 36. So these are multiples. What are the factors of 12? So if I'm talking about the factors of 12, so the factors of 12 should be 1, 2, 3, 4. That means I have to go for the LCM for 12. So I can first divide it with 2. So I got it as 6. Again, I can divide it by 2. So I got it as 3. Again, I can divide it by 3. So I got it as 1. So all of these like 1, 2, 3, 6, 12, all are the factors, and 2 into 2, 4, all are the factors of the number 12. A square number is simply when the number is multiplied by itself. So that's like if I want to get the square of 5, so that has to be 5 into 5, and that's 25. If I want to get 6 square, so that has to be 6 into 6, and that's equals to 36. Now, indices is something which is written in parts, and we'll come to that also. The reciprocal of a number is simple if we divide that number by 1. That means if I want to find the reciprocal of a number n, so I divide that number by n. So 1 is divided by that number, and that's what we say as reciprocal. Suppose if I want to get the reciprocal of 5, so 5, 1, I'll divide 5, and 1 by 5 is the reciprocal of the number 5. So that's how the reciprocal part of a function works. The other things that we are dealing with this is HCF and LCM. So suppose if I have to find the HCF and the LCM, that's highest common factor and lowest common multiple. Suppose if I have the numbers like 2, 4, 6, 8, 10, like this, and I have to find the lowest common multiple or the LCM of it. So that means I can write those numbers like this: 6, 8, 10. I'll first find a common divisor that divides the number. So that means if I divide it by 2, so I have 1, 2, 3, 4, and 5. Again, I can find one of the common divisors is 2 again. So this is 1, this is 1, this is 3, this is 2, and that's 5. Now I don't have much of the common divisors, so I can divide by 2. So that's 1, 1, 3, 1, and 5. Now the number left are 3 and 5. So I'll have 3. So that's 1, 1, 1, 1, and 5. I can again divide it by 5 to get it as 1, 1, 1, 1, and 1. So once I get all ones over here, so I'll multiply all of these divisors to get the lowest common multiple. That means if I'm doing LCM of this, so that has to be 2 into 2 into 2 into 3 into 5. So that's 2 into 2, 4, into 2, 8, into 3, 24, and into 5 is 120, is the lowest common multiple of all of these numbers. Now again, if I have to find the SCF of two numbers, say 48 and 54, if I have to find the SCF, I'll again make an LCM part of 48, so that's 2, so that means 24, again 2, so that's 12, again 2, so that's 6, 2, so that's 3, and that's 3, so that's 1. So I can write for 48, the factors has to be 2 into 2 into 2 into 2 into 3. So those are the factors that we are getting. Again, if I have to write 54, so I'll again factorize the same. So that literally means if I'm writing for 54, I'll again make up an LCM. So that's 2, that's 27, that's 3, that's 9, 3, 3, and that's 1. So that means if I'm writing for 54, so it has to be 2 into 3 into 3 into 3. So this is the, now I'll check out how many common pairs are there. So one common pair is 2, 2 here, and the other common pair is 3, 3 here. So if I'm writing the highest common factor between 48 and 64, so that has to be 2 into 3 which is equals to 6. So that's the answer for the SCF and the LCM part of it. Now, moving ahead, we also go for couple of problems which is related to rational and irrational number. So any rational number can be written in the form of a by b, where a and b are whole numbers. So now we are going forward for rational and irrational numbers. Very important part is rational and irrational numbers. In this case, rational numbers are the numbers in which they are written in the form of a by b and can also be represented where a and b are integers. So that means if I'm putting down the definition, so an irrational number cannot be written, that's it for irrational number, in the form of a by b where a and b are integers, just like root 2, root 5, pi, cube root of 2, all are irrational numbers. In general, root n is irrational unless n is a square number. In this, so we exactly have got, for an example, suppose if I'm having a right angle triangle like this where I have 1 and 2. So if I want to find the hypotenuse using Pythagoras theorem, so that's root 5. So root 5 is an irrational number as it cannot be expressed in the form of a by b where a and b are both integers. So that's the form of rational and irrational numbers. So we'll discuss it through an example. So it's pi by 2. If I'm talking about pi by 2, so definitely, since pi is an irrational number, so pi by 2 will also be irrational. Now, if I talk something about root under of 17 whole square, so that is 17 and that can be expressed in the form of 17 by 1. So that's a rational number. Now, moving ahead, we go for the sequence part of it. Now, the other things that we need to discuss is the sets part and the standard form into this. So now we'll be moving on to a part which is called sets. Now, what are sets? Sets are basically the set of numbers that is used to define a particular homogeneity, a particular homogeneous kind of things. So that's where we have to use the set part. Now, couple of definitions are very important for sets. If I'm finding out a definition for set, we'll put couple of features over here. So that means if there are sets of numbers like integers, so the things are defined as like this. So what is a set? So a set is a collection of numbers or objects. Each object is called an element or the member of set. So that's the basic definition for sets. Now, moving ahead, if I go by the set notations, so there are a lot of things to be defined for set notations. So I'll put it up with an example. So that means if, so these are few examples which we need to illustrate into a set. So now, this symbol is a Greek alphabet. It means epsilon. So this is pronounced as epsilon. And it means that is an element of or it is in the set. If I just cross that, that means it's not an element or it's not in set A. If I put n as A, that means the number of elements in set A. For an example, if I take up a set M where we have numbers like 4, 8, 12, 16, 20, 24, 28. So we can say that 12 is an element which is belonging to the set M. It's present in the set M. And 19 is an element that does not belong to M. There's no 19 inside this M. And the number of elements in set is 7. So that means we are counting the numbers. So that's 1, 2, 3, 4, 5, 6, 7. So the number of elements are 7. Then the other definition is finite and infinite set. Set A is a finite set if number of elements has a particular defined value. That means we can count it. A is an endless number of elements where we say it's an infinite set. So that literally means like the stars in the galaxy, or we can say hairs on human being, right? So this is something which we cannot count, and that comes under infinite set. Very important, when two sets are said to be equal, two sets are said to be equal if they contain exactly same elements. That means, for example, you can see this 2 3 5 7, and this is 5 3 7 2. Although the numbers are jumbled, but they are containing exactly same elements. So these are called equal sets. What is a subset? Set A is a subset of B if every element of A is also an element of B. So we write it as, that's the notation for the subset. For example, if I take that A is 1, 3, 6 and B is 1, 2, 3, 5, 6, 7, then every element of A is also an element of B. So A is a subset of B. As you can see that 1, 3, 6, if I talk about, so that's also present in set B. So A is a subset of B. A is a proper subset of B if every element of A is also an element of B, but A is not equal to B. Then we write as this notation, as you can see, the dash goes out, and then it's a proper subset. Now for empty set, the empty set is defined as null. Sorry. So empty set is defined as phi, or there's no element present. For example, the set of multiples between 1 and 4. So set of multiples of 5 between 1 and 4. So we don't have any multiple of 5 between the digits starting from 1 and ending at 4. So it will be an empty set. Empty set means there is no elements. So this is the basic fundamental examples for sets. Now, moving ahead, if I go forward and if I ask you a couple of questions about this. So the first one is, if there are two sets, set S and set T. So since they have said find the number of elements in set S, so that means I can count 1, 2, 3, 4, 5, 6. So there are six elements. So if I'm writing number of elements in S, so you have six. This usually comes for 1 mark. So if you're writing and calculating it correctly, you get 1 on 1. Or if you make any errors in calculating the number of elements, the entire marks goes out. Similarly, the number of elements in T is 4. So get 1 full mark correctly if you're writing this correctly. Now, so moving ahead, we have the other types of questions asked to this. So we'll place one full question. Now we are coming to something which is called complement of set. So complement of set is something which is not the element inside the set. So that means if I'm putting up for the definition of complement of set, so it looks like this. The complement of set A is the set of all elements in the universal set that is not the part of A. So that means basically if I'm drawing, if these are the sets elements A. So A bar is something which is lying outside it, or we can also write it as A dash, which is not inside the element A. So if I'm explaining that as a part, if suppose we have a universal set of numbers like starting from 1 to 9, if I just place it here. So universal set is from 1 to 9, as you can see, and if A is having elements 2, 3, 5, 7. So A dash will be the set of elements which is not in A. So that means excluding 2, 3, 5, 7, we have 1, 4, 6, 8, and 9 in the universal set. So A complement is the number of elements not in A but present in the universal set. Moving ahead, we go for the intersection and union. So very important part is for intersection and union of a set. So if I'm going about with the intersection, So in basically, if I draw a Venn diagram, so intersection is something which is common to both the circles. So this part is called intersection. That means it is to be common to both the sets A and B. The intersections of two set A and B is a set of elements that are in both set A and set B. The intersection is written as A intersection B. For an example, if A is having 2, 5, 7, 9, and B is having 3, 5, 9, 10. So we can see that 5 and 9 are the elements which is present in both the sets, and that's for what it's written as intersection 5, 9. The two sets A and B are disjoint if they have no elements in the A intersection B part. So that means if I have a set A, which is 1, 2, 3, 4, and I have a set B, which is 5, 6, 7, 8. So we don't have anything common over here. So in that case, the intersection part is a null set and is set a disjoint set. So that's the part how we use a disjoint set here. Now moving on to the union part of it. So the union of two sets A and B is the set of elements in either A or set B. The union of A union B is written as U. So that means we are talking about the entire thing in A and B, and this written as union. So that's a representation of U. For an example, if A has sets 2, 5, 7, 9, B has 3, 5, 9, 10. So if I'm doing the union, so see 5 and 7, 5 and 9 are in both the sets, but we will write it as once only. So that's 2, 3, 5, 7. I will not write it as twice. We'll only write it as once. So that's the union part of any set. Now, moving on to the other numbers, which we said special number sets. So that means we have natural numbers on the number line. So we'll represent all of these on the number line. So a couple of representations on the number line are, if n is the natural number, so that means it starts from 0 and it's 1, 2, 3, 4, 5, 6, a set of natural counting numbers. So as you can see, it starts from 0 and just goes on like that. So that's the number line representation of natural numbers. If I talk about the set of integers, it starts from 0, it can be plus, minus. So the only difference between natural numbers and integers, as you can see, there's plus minus sign. Also, so the line extends both the ways. Now moving ahead, if I want to write only positive integers, so that's how it's represented on the number line. So yeah. So that's the set of all positive integers. As you can see, it starts from 1 and goes on to 1, 2, 3, 4, 5, 6, 7. So this is all the sets, and this numbers goes on for the positive integers on the number line. Now we have to write, just check out a couple of concepts over here. So if I ask you, is 2 belongs to positive integer, and I ask you whether that's correct or not. So if I go by the set of positive integers, so it starts from 1, 2, 3, 4, 5. So yes, I can see that 2 is a part of positive. Not C plus means positive. So that statement is true. So usually it comes for a single mark. So if you're able to write the correct answers, you get the full mark for it. Now, if I say that minus 5 is a part of Z positive, is that true or not? No, that's a negative integer, so that's false. That's not the part of positive set. So that's how we get questions based on these part. Now moving ahead is we say as interval notations on number line. So that means if I want to write down a number, say if I want to say that x lies between 3 and 8 on the number line. So if I'm drawing the number line, so starts from 0, so I can write 1, 2, 3, 4, 5, 6, 7, and 8. So since we have less greater than and less than sign over here, so that means we'll put a bubble over here. Very important, as you can see, it's a hollow bubble, and that goes from 3 to 8. So it's a hollow means that it's either less than or greater than. The only difference is if I would have written it like this, so in that case, we would have put up a filled in bubble or a bold bubble, as you can see, and goes from 3 to 8. That means if equal to sign is also there, so then we have to put up a bold bubble. And if there's less than equal to sign, we place up the hollow bubble over there. So that's the interval notation that we usually put it for the number lines. So for an example, they ask you a lot of questions based on number lines. So I'll just take up two to discuss. So that means if you're putting these two numbers on the number line, so as you can see, I'll draw the number line from 1 to 6. So again, starts from 0. So that's 1, 2, 3, 4, 5, 6. So I'll name it. Now, it's greater than equal to 1 and less than 6. So that means here it's the bold dot will hold because there's an equal to sign. At 6, it's a hollow bubble, and that's my number line, and that's the answer. Similarly, if I'm going for the edge part of it, so it starts from 0 and the number line is at -1. So it's greater than -1 and it's in 0. So that's -1 and that's 0. Again, at both, so that's the number line. So that's the answer for the number line part of it. Now moving ahead, we also discuss couple of questions on the Venn diagrams. So if I'm going on ahead with the Venn diagram part of the set, so there are two important parts that's normally asked under Venn diagrams is this. As I already discussed before, so that's the intersection part and that's the union part, as we can see through the diagram. Now, if I have a universal set of the numbers, that's an example question which we'll discuss and we'll even discuss the mark scheme for this. So yeah, suppose they give you a number where the universal set is from 0 to 10 and x belongs to all integers. A is the set 2, 3, 5, 7 and B is 1, 3, 6, 7, 8. We have to find the intersection and the union. As I already suggested, that intersection is the element which is common to both. So if I can see that the element 3 is common to both. And union is all the digits, but we shouldn't repeat the number of digits. So if we are writing down the answers for this, so the answer for this or the explanation for this is this diagram. As you can see for intersection, there are only two sets which is common. So one is 3, the other one is 7. So in the intersection part, we have written 3 and 7. In set B, so that means the part which is in set B, apart from 3 and 7 is 1, 6, 8, which we have written here. In A, apart from 3, 7 is 2 and 5, which we have written here. And in the universal set, there are the remaining numbers. So now, that's how is the illustration on the Venn diagram works. Now, moving ahead for the Venn diagram of the regions. So that literally means if I'm putting up the complements of the set under the Venn diagram regions, and if I'm verifying a couple of things like an example, they asked you to verify this. So that means A union B whole complement can be written as A complement intersection B complement. So the shaded region A union B is written as now. If the shaded region is union, as this is marketed, so the anything outside this set is a complement of it, right? So that means A bar and B bar is represented by these things. That means which is not in A and not in B. So A bar intersection B bar is represented by the universal set. So that means it's verified that A union B dash is A dash intersection B dash. Now, we'll come up with a thing where we have to do a problem solving using a Venn diagram. That's a very important. So suppose if we have a question which is like this. So, a sports club has 75 members. 42 members play tennis, 53 members play hockey, and 27 members play both of these sports. Draw a Venn diagram to display this information, and once, uh, hence, determine the numbers who play neither sport or at least one sport. Now, if I go by the explanation of this, so that's how the Venn diagram works. So, yeah, just a minute. Yeah. So let T be the number of sets who plays tennis and H be the number of sets who play hockey. So for intersection, we have 27 because it has said that 27 members play both of these sports. Now, number of plays tennis but not hockey is 42 minus, because 42 members play tennis. So 42 minus 27, so that's 15 here. Again, number of does not play tennis nor hockey is 53 minus 27, so that's 26 here. And the rest all is in the universal set. So seven members play neither the sport, so that's the answer here. And 75 minus 7, so that's 68 members at least play one sport. So that's the explanation for the sets and the Venn diagram part. Now, the other two things is indices and standard form. So we'll now be discussing something about indices and the standard form. So the next topic that we are discussing is indices, or even known as exponent form. Now, the couple of formulas that are described under indices is if I'm multiplying a like that till n number of times, so I got it as a to the power of n. Number two, if x to the power a is multiplied by x to the power b, since the bases are same, so the power gets added. Number three, if I'm writing x to the power a divided by x to the power b, and again since the bases are same, so the power gets subtracted. Number four, if I'm writing x to the power a and whole to the power b, so the power gets multiplied, so that's ab. Number five, if I'm writing nth root of x to the power a, so that can be written as x to the power of a by n. Number six, if I'm writing x to the power 0, so that can be written as 1. So these are a couple of rules that we follow under indices. So if I go for negative indices also, so if I write x to the power minus a, so that's written as 1 by x to the power a. So it just simply becomes the reciprocal of it. Now we'll discuss it through the problems. So suppose if I want you to calculate the value of 2 cube, so that means I can write 2 into 2 into 2 for 3 times, and that's equals to 8. So that's the answer if I'm writing it for 2 cube, and usually is asked for a single mark question. Again, if I'm asking you the values of x to the power a into x to the power b, so that means if I have an example like this, that's 2 to the square and 2 into cube. So that means that can be written as 2 to the power 5, and that means this is 4, and that's into 8. So this is equals to 32, and we also know that 2 to the power 5 is equals to 32. So that's how we apply this rule. Again, if I have something written as 3 square over 3 to the power 4, so that can be written as 3 to the power of 2 minus 4, so that is equals to 3 to the power minus 2, and that's written as 1 by 3 square, or that is 1 by 9. So that's basically, again, if we are solving this, so that is 3 to the power 2, so that's 9, and 3 to the power 4 is 81. So again, if we are cancelling this, we get the same answer as 1 by 9. Now, if I'm writing something as fourth root of 16, so that means we can write it as fourth root of 2 to the power 4. And that means it becomes 2 to the power 4 by 4. That's equals to 2. And that's the answer about the fourth root of 16. Now we go into some of the questions that's been asked on indices, and we'll try to project few answers to those. Now, suppose we have got a question like 8xy squared into 2x squared y cubed. So if you have to multiply, so it first multiply the numbers, which is 8 into 2, so that's 16. Now into x gets multiplied with x squared, and y squared gets multiplied with y cubed. So we'll use the indices, so that's 16. That's x to the power 1 plus 2, and that's multiplied y to the power 2 plus 3. So that we got it as 16x cubed and y to the power 5. So get one full mark for writing this answer correct. This usually comes for 2 markers or even 3 markers. So one mark you get writing this part correct, and the other mark you get correct by writing the final answer. That's how it's a 2 marker question. Now moving ahead with the brackets part and simplification part. So if I say that if I have to write, say suppose 4 by x and that's whole square. So I can write the numerator square individually, which is 4 square, and then the denominator square, which is x square. So the correct answer has to be 16 by x square, and you get one full mark for writing this answer correctly. Now we go for a zero or a negative exponent. So suppose for a zero or a negative exponent is, if I ask you to write 2 by 3 and that's to the power of minus 2. So that means you have to just reciprocate it. So that's 1 by 2 by 3 whole square. So again, we'll follow the same rule. So that should be 2 square divided by 3 square. So that means 3 square over 2 square, and that is equals to 9 by 4. So that's the correct answer, and you get a mark for writing this correctly for the negative exponent. So these are all the indices questions that can be asked in an examinations. So now we are moving on to something which is known as a standard form. Very, very important to write down the standard forms. If I'm moving for the part which is called a standard form, it's a very, very important topic that's always asked in IGCSE examinations. Now, what is a standard form? First of all, so please remember the definition. I'm putting it up here. So a standard form involves writing a given number as a number between 1 and 10 multiplied by an integer to the power of 10. So that means if I have to represent it in the form of a into 10 to the power n, where a has to be greater than equal to 1 but less than 10. Right? Now that's the restriction that we follow for standard form. So I can show you a couple of examples how to put it into the standard form. So now that means, suppose if I ask you to put up a number 27 into the standard form. So 27 can be written as 2.7 into 10. So see, 27 is written as 2.7 into 10. Why we are writing this? So see, we are satisfying all the rules of standard form. So a is this value and into 10 to the power, and the value of n is 1 over here. So the standard form is satisfied. Suppose if I'm writing 580, so that means I have to do 5.8 because this is the value of a that's lying between 1 and 10, and that has to be multiplied by 10 square. So all the standard form is satisfied. Similarly, if I'm going for a 3-digit number, so that's done like that. Now, if I want to go for a decimal number, so suppose if I want to go for 0.75, I have a number called 0.75. So if now I want to represent it into the standard form, so the way of doing it is 7.5 divided by 10. So that means it's 7.5 into 10 to the power of minus 1. So that's the standard form of a decimal number. Similarly, if I have another decimal number, say 0.006, 0.006. So I can write this number as 6 by 1000. That's how we can represent. So that's 6 into 10 to the power minus 3. That's the standard form that we are looking for these type of numbers. Now, They can also give you a variation in these type of problems where they can ask you to multiply two standard forms. Suppose if I ask 2 into 10 to the power minus 3 into 7 into 10 square. So what's the standard form of this? So first multiply the digits, that's 14, and then multiply them. So 10 to the power of minus 3 plus 2. So that means we got it as 14 into 10 to the power of minus 1. Now 14 does not satisfy the A criteria. So that means we have to put it into the A form. So that literally means this is equals to 1.4. So this is equals to 1.4 into 10 to the power 0. So that can be one of the standard forms that we are looking for. Now, similar way goes for the divisibility also. If it's 6 into 10 to the power 3, and that's divided by 2 into 10 to the power minus 3. So we'll first cancel out the digits. So that's 3, and that's 10 to the power 3 minus of minus 3. So that's 3 into 10 to the power 6, and that's the standard form notation. So this usually comes for 2 marks. You get 1 mark correct for writing this step correctly and 1 mark for writing down the final answer. Similarly, you get 1 mark correct for writing down this step correctly and 1 mark for this answer. So that's how the standard form of these works. Now, so this is the ordering and the sets and the powers and the rules of the number system that we have to discuss in the first part of the unit. So now, apart from this, we will be discussing few board questions that's asked on the concepts that we have discussed today. So let's go for a few board questions to be discussed. Now, one of the board questions that's been asked in indices is 2x squared y cube, and that's whole cube, and that's divided by 4xy, and that's whole square. So now we can write this as 2 cube into x squared whole cube into y cube whole cube, and that's divided by 4 square into x square and into y square. So 2 cube we can write it as 8. So using we can write it as x to the power 6, and that's y to the power 9. And that's divided by 16 into x square into y square. So we can cancel this out. So that's 2. So we can write it as half, and that's x to the power of 6 minus 2 into y to the power of 9 minus 2. So the answer has to be half into x to the power 4 into y to the power 7. So that's the final answer. So get 1 mark for writing this correct, 1 mark for writing this step correct, and 1 mark for writing this. So it's a 3 marker sum, and you get whole 3 marks for writing these steps correctly. The other type of board questions asked is on HCF and LCF. So they have asked you what is the SCF of two numbers, which is 12 and 18. So again, we'll use the common multiple. So that means we'll find the LCM of it. So that's 2. So this is 6. That's 2. So that's 3. That's 3. So that's 1. So that means it can be written as 2 into 2 into 3. And again, we'll make up an LCM for 18. So that's 2. So that's 9. That's 3. So that's 3. And that's 1. So if I'm writing it for 18, so that's 2 into 3 into 3. So again, I'll find out the common sets here. So the SCF of the number is equals to 2 into 3, and that's equals to 6. So you get 1 mark for writing this correct and 1 mark for calculating this properly. So you get full 2 marks for that. The other question asked in board is for LCM. So that's 18, 20, and 24. So we'll find a common multiple, which is 2. So that's 9, 10, and 12. So we again divided by 2. So that's is 9, 5, and 6. So now other divisor has to be 3. So that's 3, 5, and 2. So again we divide by 2. So that's 3, 5, and 1. So again by 3. So that's 1, 5, 1. And then again by 5. So as we can see, everything is reduced to 1. So the LCM of this has to be 2 into 2 into 3 into 2 into 3 into 5. So that means if you are multiplying, so 2 into 2, 4, 3, 12, into 2, 24, into 3, 70, 2 into 5 is 360, That's the LCM of the given number. The other board question that asked on the numbers that we have discussed so far is the standard form. So that means they have asked you to find out 3.5 into 10 to the power minus 7, and that's multiplied by 2 into 10 to the power 9. So that's a two marker question. So we'll first multiply the numbers. So that's 3.5 into 2 into 10 to the power 9 into 10 to the power minus 7. So we got it 3.5 into 2 is 7, and that's 10 to the power 9 minus 7. So that's 7 into 10 square. So that's the final answer. So you get 1 mark for writing this correctly and 1 mark for calculating this part correctly. So get full 2 marks in a similar way. Now, that's for the standard form. The other questions that are asked on the things that we have discussed today is on sets. So they give you a set A, which is 1, 2, 3, and 4. They give you a set B, which is minus 1, minus 2, 3, 4, and 6. They asked you what is A intersection B. So that literally means we have to look for the common elements. So 3 is common in both, 4 is common in both. And if you write A intersection B as 3 comma 4, so you get full 1 mark for this. Then they asked you about the union part, in which you have to write all the elements like minus 1, minus 2, then you have 1, 2, 3, 4, and 6. If you write this correctly, you get 1 full mark for this. Then they asked something which is the number of elements in A. So that is equals to, we can count, so it's 1, 2, 3, 4, and the number of elements in B, which is equals to 5. So you get full 1 mark for writing these correctly. So these are a couple of questions asked so far in IGCSE numbers in the topics that we have discussed in this session. Please feel free to reach us if any queries and all. We'll be going with the further revisions of numbers also in coming weeks. So please join us, ask any queries. Thank you, students.